This is Christian Avalos with the Screencast assignment for Chapter 6, where we were asked to find the coefficient of friction between the man's shoes and the ice and between the car's tires and the ice. Here's my work. So I started by listing all our knowns. We knew that the initial frame, which was once, and I'm doing the guy sliding on ice first, I'm sorry. So we knew that the initial frame, that's when the man first, as he's running, and then he stops running, and that's when he begins to slide. And that initial frame was 30 frames, the final frame was 110 frames, that's when he came to a complete stop, and that the rate was 30 frames per second. You know that the final velocity is 0 meters per second because he comes to a stop, and the total distance that he slid across the ice was 7.5 meters. Then our unknowns, we don't know the acceleration, we don't know how long he slid for, we don't know the coefficient of friction, which is what we need to find, and we don't know the initial velocity or the average velocity. Then I drew a free body diagram of the man, and the only forces acting on the man once he stops running and he's just sliding on the ice, it's the normal force, his weight, and then the friction force, which is causing him to eventually come to a stop. Then I started by finding our time. So I just did the difference in frames, which gives us 80 frames, and then I convert that and divide it by the rate, which is 30 frames per second, and that gives you 2.67 seconds, and that's the total time that the man slid across the ice until it came to a stop. Then I found the average velocity by just doing distance divided by time, which is 7.5 meters divided by 267 seconds, and that gives you 2.8 meters per second. But that's only the average velocity. But then you can calculate the initial velocity with that, because average velocity is also VI plus VF divided by 2. And you know that VF is 0, so you can rearrange the formula like how I did here. Solve for initial velocity, which you get 5.6 meters per second. And then I went on to find the acceleration of the man as he slid across the ice, and I simply did that by the difference in velocity divided by difference in time. And you know that the final velocity was 0, initial was 5.6. You knew that the final time was 2.67 seconds, and the initial time was 0 seconds. And that gives you negative 2.08 meters per second squared, and that is the acceleration. Then I used the formula kinetic friction equals negative m times a, and then I also knew that the net force equals the weight force, which is m times g. And then if you use the formula, the coefficient friction equals Fk divided by n, which equals negative ma divided by mg. And then if you plug your numbers in, the m's here cancel out, and then you're just left with 0.21, and the coefficient of friction is dimensionless, so that is the answer for the guy's shoes between the ice. That is the coefficient of friction. Then I went on to doing the same thing, but this time for the car's tires and the ice. So again, I started by listing all our knowns. The initial frame, the final frame, the rate was the same, 30 frames per second, but this time the distance that the car slid across the ice was 8 meters, and of course the final velocity was 0 meters per second, again because the car came to a stop. Our unknowns are the same thing. We need to find the acceleration, the time, initial velocity, and the coefficient of friction. I again drew a free body diagram here, and the forces acting on the car is the same as the man. You just have the normal the normal force, the weight force, and the kinetic friction. I then solved for time. I found the difference in frames, which was 85 frames, divided that by the rate, which is 30 frames per second, and that just leaves you with 2.83 seconds, which is the total time that the car slid across the ice. Then I found the average velocity by dividing distance by time, and got 2.82 meters per second. And then I found the initial velocity here by rearranging this formula like I did for the man, and I got that the initial velocity was 5.64 meters per second. Um, and then I found the acceleration of the car as it slid across the ice, which was negative 1.9 meters per second squared, which makes sense because it's slowing down, so the acceleration is in the negative direction due to friction. And then here I've solved for the coefficient of friction. And again, you know that kinetic friction is the same thing as negative m times a. The normal equals the weight force, and which equals m times g. And that the coefficient of friction equals kinetic friction divided by normal force. And then you can substitute negative ma for kinetic friction, mg for normal force, and then plug in your numbers. And then your coefficient of friction is 0.19. And again, it's dimensionless. And there's not that big of difference between the coefficient of frictions between the man's shoes and the car's tires. And that is how you find the coefficient of friction.